Yeah.
Do you think, though, that, I mean, I've wondered about this many, many times. I wonder if it's an outdated idea, this idea of traveling to the stars. And again, I go back to this whole interdimensional thing, that I wonder if that's the reason why we have never been visited by other planets, by species from another planet. Maybe that's not what happens. Maybe they develop artificial realities. Maybe like what Jamie was talking about to me with these artificial computer realities. Like if someone develops some sort of a matrix-like world where you can plug into it and experience an infinite number of things in an infinite number of artificially created dimensions that are indistinguishable from this, why would you want to risk a 6-month trip in a metal tube to another planet? I mean, maybe that's really retro. Maybe that's a really ancient way of looking at things. Maybe it's like zeppelins, like big flying balloons instead of,
So, the question you've raised is called the Fermi paradox.
Right.
Which is just given there's so 100 billion stars in our galaxy, 8 billion galaxies in the effectable universe, 100 billion in the observable universe. The universe is also pretty old, 15 billion years old. So if it was the case that life is very common, that it's very easy for us to, life to then develop to a level of advanced technological ability, we should expect to see evidence of aliens all over the place. Right. But yet we see absolutely none. And that means that from a habitable planet, somewhere along the path from habitable planet to kind of spacefaring civilization, there must be some big filter. There must be some step that's just incredibly hard for that to, or incredibly unlikely that civilization moves them, or life moves from that step to another. And one hypothesis is this, people just, civilization gets to a sufficiently advanced level and they just chill out. They just
Or they go internally.
Yeah, they go internal. The issue with that explanation, I think, is it's just not strong enough. Because, you'd have to think that for this kind of filter to work, it has to be a really strong filter. As in because there's just so many stars, so many Earth, so many seemingly habitable planets.
Right.
It has to be the case that it's exceptionally unlikely at some stage or other, and not just really unlikely, as in 1 in a trillion unlikely, on this path from habitable planet to spacefaring civilization. And so you'd have to think of a trillion civilizations that get to this level of technological ability, they all choose to turn inward. And that seems just very unlikely. It seems at least one would really try and spread out. And if so, then we'd see evidence of that. Because cosmically speaking, the time from getting to the level of technological capability where you can spread to the stars and the level where we'd be able to kind of see real evidence of that is kind of small. So I actually think that the reason that we can't see aliens is because the very first stages of life are incredibly unlikely. The move from nothing to kind of basic replication, and then secondly, the move from single-celled organisms to multi-celled organisms. And the reason for thinking this is very unlikely is it took an incredibly long time on Earth, billions of years before this happened. And in particular, in the move from single-celled to multi-celled life, that's only ever happened once. And so, given that we don't see any aliens, we should think some part of this is really hard. Our best guess is that move from single-celled to multi-celled, and perhaps from the creation of the first cells as well, that was incredibly difficult. And that means that we're just exceptionally lucky to be alive, as it were.
But if the universe is infinite, that means that this has happened an infinite number of times.
That's right. Though very far away, sufficiently far away that we are not connectable to we can't contact each other or observe each other. So.
But there's an infinite number of those infinitely far places.
Yes. So there would be some clusters of the universe. And again, the idea that the universe is infinite, it's only a hypothesis.
Right.
And I'm just deferring to other people who say it's the leading hypothesis.
Well, the most puzzling hypothesis to me was the evidence of supermassive black holes being at the center of every galaxy. and that the hypothesis was that the supermassive black holes are exactly 0.5% of the mass of the entire galaxy, and that if you go through those supermassive black holes, you may in fact go into a completely new universe filled with hundreds of billions of galaxies, each with supermassive black holes at the center of those galaxies, which will take you to hundreds of billions of galaxies in another universe, and that it's never ending, and that's what the real infinity is. It's not just the mass of all the things that we can observe in the 14 plus billion light years that we know of from the Big Bang to today. It's all of those things being portals to incredibly different, totally new universes.
Okay, yes, it's turtles all the way down.
Turtles all the way down. So the real question to me, and this I proposed this to Brian Cox, and I didn't get a sufficient answer. It's why would we assume that there's someone more advanced than us? Like, it is possible that someone, some species, something is the tip of the spear. That something is the first, that something is the most advanced life form in the universe. Why would we assume that someone would be more advanced than us if we are the most advanced thing that we can find? The only logic that I could point to was that we are relatively young in terms of the history and the age of the universe itself. The universe itself being roughly 14 billion years old. We are 4.6. What are we? What is the age of the Earth?
Yeah, but
somewhere in there.
That sounds about right.
Somewhere in the neighborhood, right? Relatively young when you consider that 10 billion years of life, give or take, happen or of existence happened before we came along. But why would we assume that there's anything out there that's more advanced? And why would we assume that this isn't as far as anybody's ever gotten?
Yeah.
I mean, that's
so
in terms of infinity, right? 14 billion years seems like a long time, but in terms of infinity, it's a blink.
So I think we should believe that and again, let's now just ditch the infinity and just think about the observable universe, which is finite.
There's people pulled over sweating in their car right now.
Yeah,
What
exactly.
the fuck?
Infinity, have you ever heard of Graham's number? This is now a total digression of Graham's number.
I don't believe so. What is Graham's number?
It got known as the largest number ever seriously used in a mathematical proof. And Tim Urban of Wait But Why has this amazing post trying to explain just how big Graham's number is. And that you have to use a special notation in order to be able to explain it. And numbers just get really big. And once you really start to think this through, you're just like, you're left just kind of rocking back and forth. Like, not like just totally
Untenable.
freaked out. Yeah.
For our little
you
monkey
think like
minds.
trillion is so big.
Yeah.
Trillion is just a speck of dust compared to Graham's number.
Even a trillion years is a speck of dust. When you consider the possibility of the universe itself being infinite, or the possibility that is a continuous cycle of big bangs to expansion to contraction, back to an infinitely small point, back to another big bang, which is a plausible possibility.
Yeah, I mean, I think. Yeah, I'm very worried. You know, I'm not Neil deGrasse Tyson.
Right.
I'm sure I'm butchering tons of the science. I think my understanding at the moment is that we currently think that the universe is just expanding and it just keeps expanding forever.
Right.
I know it's definitely a leading theory that it was going to expand and slow and then kind of crunch.
Yes.
But you mentioned humans being the most advanced kind of creature. I think that probably is correct in the observable, or certainly our galaxy, let's say.
In our we know it is in our solar system, right?
Yeah, that's right. But I think we know it is in our galaxy as well.
You think so?
And again,
it's so far.
But the thing is that it's far as in it's like 100,000 light years. But when you're thinking when you're thinking about 15 billion years of the age of the universe, that's actually just a very short period of time.
Right. But why would you assume that 100,000 light years from now there's not something exactly like us?
So it's possible, but the thing is that if it was somewhat easy, or if it was just not incredibly difficult for intelligent life to evolve, then it would have happened in the past already, and we would see evidence of it. And the fact that we don't see any evidence at all of intelligent life on other solar systems, or at all, suggests that it's incredibly difficult for that to happen.
But isn't that like being in the woods and unzipping your tent and sticking your head out and saying, I don't see anything, this must be empty woods?
It's more like, I mean...
You're talking about a very small area that you've observed and we've taken account of.
So I think it's more like, because I think if an alien civilization or us in the future goes to kind of start, spreading to the stars, in the course of, just a few seconds, a million years, let's say, there will be really significant evidence. You'd see Dyson spheres being constructed around suns, to harness the sun's energy. You'd see some evidence of like galactic engineering projects and so on. It would be like a really big impact.
But you think you'd see that with hundreds of thousands of light years between us and the observable objects?
But again, 100,000 light years is just not very long compared to the kind of 15 billion. So it would just be this amazing coincidence if it's the case that a life that's as advanced or more advanced than us has evolved at just the same time as us, where 100,000 years, give or take, is basically just the same time, but hasn't evolved hasn't evolved more than a million years ago, where we would start to see kind of major impact of that.
So if something within the observable universe, but we've observed so little. We don't even have really adequate photographs of anything outside of our solar system.
Yeah.
I mean, everything is just radio spectrum, the analysis that they're getting off of light waves of what the components of the atmosphere is. And
so using your analogy, what I'm suggesting is that if it was the case that alien life was intelligent life was not that hard to come by, you'd stick your head out the tent and you'd look like Tokyo rather than looking like the woods.
But why does it have to look like Tokyo? Why can't it look like Kansas? Why can't it be like really spread out and very little life?
Because I think if life is spreading out, then it's just going to want to, what does life do? It just tries to harness resources and tries to grow more of itself. And
maybe it reaches a point where it realizes that's futile. It just concentrates on effective altruism at home.
Oh, perhaps.
Its home star.
So that's the turning inward suggestion again.
Yeah.